Hi everybody, once again, we're on a new chapter here, chapter 6.5. We're looking at rational equations. Now what we've looked at so far are rational expressions. We've simplified, we've added, subtracted, multiplied, divided, a combination of those. We've done a lot of factoring, but we've simplified rational expressions. Rational equations are equations where it has an equal sign in it. We're solving equations. We're trying to find the number that when I substitute an x here and here, will make the left side simplify down to equal the right side. Rational equations have the variable in the denominator. So we're going to look at a couple of ways of doing this. Now if you recall, let's take a look at this. Here's an equation. X over 3 plus 7 over 2 equals 61 over 6. What's unfriendly about this? Well, it has fractions in it. We don't want to use fractions, but if you recall, there's a multiplication property of equations. We can multiply the equation by any number we want. We can come up with a new equation that will have the same solution as this equation. So, we can start by identifying the lowest common denominator between 3, 2, and 6. It's 6. We're going to multiply each term in this equation, the numerator, by the LCD. So 6 times 6x, that's 6x over 3, plus 6 times 7, that's 42 over 2. And 6 times 61, what is that? 6 times 61. I believe that's 366 over 6. I'm going to give you some time here. See if you can solve this. Okay, and when we simplify this down, 6x divided by 3, that works out to 2x. Plus 42 divided by 2, that's 21. Equals 366 divided by 6, that's 61. We got a new equation. We know that this new equation has the same solution as the original equation, but it doesn't have any fractions. It's more friendly to work with. So we'll solve this equation. Subtract 21 from both sides. We have 2x equals 40, and x equals 20. We just solved the equation. If we put 20 into x here, simplify it down, the left side will balance the right side. And you can do that yourself. Well, it's the same idea with rational expressions. We'll get to that in a moment. Okay, so solving these equations here. We have a rational equation here. It has a variable in the denominator. We can do this. We can make it more friendly too. Always factor all your numerators and denominators first. We got to see if we can cancel anything out top and bottom originally. Can we simplify this any further? No. How about this one? Nope. How about this one? Sometimes you will be able to in the future here. I've included a handout as well for you to follow. And this is mirroring the handout here. Now the second thing is identify your non-permissible values and then identify the LCD. And this one, from here, x, and x can't equal 0. And our lowest common denominator, between 3 and 4, that's 12, and x. So there's our lowest common denominator. Now the next thing we're doing is we're going to multiply the lowest common denominator, the LCD, into the numerator of each term. So I'll rewrite this. 5 over 3x plus 1 over 4 equals 3 over x. Now we're going to multiply that into the numerator of each term. 12x. So help me out. What's 12x times 5? That's 60x. All over 3x. 12x times 1. That's 12x. Over 4. And 12x times 3. That's 36x. Over x. We just multiplied into the numerator, just like we did in the earlier example here. Can these be simplified? Yeah. 30x over 3x, that simplifies to 20 plus 12x over 4. That simplifies to 3x. And 36 over x, x's cancel out, all we got left is 36. We got a new equation, much friendlier to work with. We're going to solve this resulting equation. You can hit pause and you can solve it. Okay, all I've done is done some erasing and I've transferred what we had down here, the resulting equation, up to here. We'll solve the resulting equation. 20 to the other side, we have 3x equals 16. Divide both sides by 3. We have x equals 16 over 3. There's our solution. Is it one of our non-permissible values? No. That solution, if you were to substitute into x here and here and simplify it down, it'll balance the left side and the right side. Okay? We'll try a couple examples here.